All right, so number 32, we have a mass spectrometer, which is this whole thing together. The first part of the mass spectrometer is the velocity selector, where you have an electric field and a magnetic field together. The idea in the velocity selector is if you look at the charge as it's passing through, so if the charge were positive, you know, this top plate here is plus, bottom plate is minus, so the force of the electric field is down. When you do right-hand rule number 1, you find the force of the magnetic field is up, and only the charges with the exact perfect velocity make it through, right? Because force magnetic is QVB, force electric is QE. So you set these equal to each other, and you get V equals, what is it, E over B? When you set those equal, QVB equals QE. The Q's cancel, so V is, E over B. Okay, so what's happening in this problem is we have two different isotopes. And you guys remember from chemistry what isotopes are? Same atom, but different mass because they differ in the number of neutrons. So these isotopes come out of the velocity selector. We're given the velocity. When they enter this second region, the velocity is 3 times 10 to the 5th meter per second. Now here's the deal. Since they have different masses, right? This one has 235 protons and neutrons. This is 238. So the masses are going to be different. So as a result of a different mass, one particle is going to have a smaller circle path, and then the other particle is going to have a larger circle path. What this question wants us to find is this distance here, right? The distance between the impact points. What is that distance there? Now, what is that distance going to be? It's going to be the difference between the two diameters. So the equation that applies when you have a charged particle traveling perpendicular to a magnetic field, the equation is R equals mv over qb. So what you got to do is you got to figure out the mass of each of these particles, right? The mass of this first guy, the 235, comes out as 3.9245, don't round it here, 9245 times 10 to the negative 25, that's that mass. And then this guy has a mass of 3.9746 times 10 to the negative 25. Now, how did I do that? Well, look, the 235 and the 238, just hold on a second. The 235 and the 238, that's protons plus neutrons. Protons and neutrons have a mass of 1.67 times 10 to the negative 27. So look, long story short, we have the masses of each particle. We got the velocity of each particle. What's the charge? Singly charged ions, what does that mean? That means that our Q is 1.6 times 10 to the negative 19, and then we're given the magnetic field. So the radius for the first particle comes out as 1.2264, and then the radius for the second particle comes out as 1.24206. Now what you want to do is get the diameter, right? The diameter is going to be double that. So this is 2.4525. The second one, just double the radius, 2.48462. And then what do? Subtract these two numbers to get the path difference, which comes out as 0.032 meters. That's the final answer.